Okay, fine. Right. So, what I can say is that you have magnetics week two part. It starts with, see, entire last week, you never questioned me what is the source of magnetic field. Entire last week, your discussion is strictly on what is happening to this charge in motion when it is moving in a magnetic field. You never questioned me what is the source of magnetic field. It started with the Oersted experiment. Oersted experiment, where he observed that a current carrying conductor can be a source of magnetic field because Oersted, while he is demonstrating the experiment of dry cells, he noted that a current carrying conductor is affecting a nearby magnetic compass. You know this, in the school you have studied. So from there, straight away, thereafter, Biot and Savard studied on different shapes of the conductors and measured the magnetic fields due to the different shapes. And finally, they proposed a law. And what is that law? Here you see, imagine that you have a current carrying conductor in this shape. Can you see that? Yes or no? Now you have an element over here. Can you see the element with the red mark? Yes, sir. Right. Now the question is, in this particular point of view, you can see that there is a point P here, there is a point P here, over here, point P. Got the point? There is a point P over here where you can see that in this particular point P, you can see that uh, there exists some magnetic field. So as per Biot and Savart, the magnetic field there existing, according to them, they said this is a magnetic field point, and according to them, the magnetic field at this particular point depends on three things. One on R, the other on the element, and the other on the angle part. I think you got my point. Yes or no? Are we clear? Paka? I repeat, it depends on three factors. One, the element. Two, the angle. Three, the position. So according to the definition or according to the observations of Biot and Suburbs, they conclude, actually they proposed that dB is proportional to ideal. dB is inversely proportional to distance square. dB is proportional to sine of the angle between them. You combine all the three, you will get this relation. Ideal bar cross R bar by R cube. This is the fundamental law. So to determine the magnetic field at a point P, due to this element, remember I am giving at the point P, the magnetic induction field strength at point P due to an element only, not due to the entire conductor. What if you want to do the entire conductor? Do the integration properly. So to do the integration properly, at every element, you need to know three things. One, ideal you need to know. Two, R bar you need to know. Three, angle. Remember, this is the angle between IDL bar and R bar. That's the angle. And this is the angle between IDL bar and R bar. That's the part. This is the theta. Okay? Next. The next part is, now we will, anyway, now we have identified that these things are our observations. And now what we are going to do is, we will do this field due to a long straight current carrying conductor. Remember, it is not infinitely long. It is a long. You can see it is starting from D, it is till C. You can see this is a straight current carrying conductor. You can see that this is a straight current carrying conductor. D to C. D to C. A long straight current carrying conductor. Now we are working about a point P over here. You can see that this is the point P over here. See the point P over here. No, see, please try to understand the point P with respect to C, with respect to D makes an angle like this. It makes an angle phi. It makes an angle minus beta. Right. Makes an angle alpha, makes an angle beta. Now the question is, right, to see that now you have an element over here. Due to this element alone, what is the field at this point? This is what I am going to do. For this purpose, I require three things: R bar, ideal bar, angle. First, I'll write R bar. This is R bar. Hello. Yes. This is R bar. Now I'm getting R bar. R bar is nothing but AP bar. AP bar is nothing but xi cap minus yj cap. Of course, modulus of R bar is root x square plus y square. Right. What is ideal bar? Simply ID by j cap. I have given three terms. Third term, you will get by itself like this, cross product. So ID by j cap cross xi cap minus yj cap. You can see here. You can see here. So what will happen thereafter is you will have this particular relation. So j cap cross I cap gives minus a k cap. So you got Ix dy minus a k cap. So I am writing what is this relation called? Biot and Savoy's law. Savoy's law. Very good. అడగమ్మా ఇక్కడ జే క్యాప్ క్రాస్ ఐ క్యాప్ మైనస్ కే క్యాపే కదా. మైనస్ బీటా ఎందుకు వచ్చిందంటే వెరీ గుడ్ క్వశ్చన్. అలా అడగాలి మీరు. ఒకటి ఏంటంటే క్లాక్ వైజ్ డైరెక్షన్, ఇంకోటి యాంటీ క్లాక్ వైజ్ డైరెక్షన్. రెండు, నువ్వు పైకి వెళ్తే ప్లస్ వై, కిందకి వెళ్తే మైనస్ వై. నేను అలా వేయలేదు అనుకో, ఇంకోలా చెప్పనా, ఇప్పుడు ఇది ఆల్ఫా అవుతుంది, ఇదే బీటా కూడా అవ్వచ్చుగా, ప్లస్ మైనస్ రిఫరెన్స్ చూపించకపోతే. రైట్. మ్యూ నాట్ బై 4π డిఎల్ బార్ క్రాస్ ఆర్ బార్ వచ్చి ఐ ఎక్స్ డివై మైనస్ కే క్యాప్ బై ఎక్స్ స్క్వేర్ ప్లస్ వై స్క్వేర్ హోల్ క్యూబ్. రైట్. So B bar is integral D bar is minus beta to plus alpha mu naught I by 4π. Right. Now I'm writing everything over here. Please try to understand that. X dy. ఈ పర్పస్ కి నేను ఏం చేస్తానంటే y is equal to x tan theta తీసుకున్నాను. dy x secant square phi d phi. ఎందుకంటే see, when you are doing integration, everything must be the same term. And one more important point is x square plus y square is what? 1 x square plus x square tan square phi. That will become x square secant square phi. So I have substituted all that in this equation. Just everyone go through this equation and confirm whether you followed it or not. Have you followed this? Right. Now you come to this relation where secant square phi and secant cube phi becomes cos phi d phi. Your limits are minus beta to plus alpha. Finally, you got beta is minus 4 minus mu naught by 4π I by x sin alpha minus sin. ఇది ఇలానే గుర్తుపెట్టుకోండి, sin మైనస్ బీటానే గుర్తుపెట్టుకోండి, మైనస్ కే క్యాప్. అంటే కరెంట్ ఇలా పోతూ ఉంటే ఫీల్డ్ ఇలా ఉంది. యూ కెన్ యూజ్ రైట్ హ్యాండ్ గ్రిప్ రూల్ ఫర్ దిస్. You stretch your finger along the right hand like this. And the curl of the forefinger represents field lines. So if you are having a current carrying conductor like this side you will have inward magnetic field, and this side you will have outward magnetic field. Why? Because when right hand thumb is in this direction, curl of the fingers will be into the plane here, outward here. So if the current is going along Y, the positive X direction you will have inward, negative X direction you will have outward. That's what you need to remember here. Now, any doubt till this point, till this box, boys and girls? Pakka. Next. Now you choose a point. I of course I agree. I agree. What if the point is outside this and at a distance x? In this case, there is no problem with beta. In the place of alpha, you should write minus alpha. In the place of alpha, you should write minus alpha. The formula becomes sin minus alpha minus sin minus beta minus k. Suppose if the point is selected over here, no problem here. There is no problem here. The only issue is that there is no problem with alpha. In the place of beta, you should write plus beta. అందుకని అమ్మా ఇందాక మైనస్ ప్లస్ అని ఎందుకు చెప్పాను అర్థమైందా మీకు? ఎలివేషన్ అండ్ డిక్లినేషన్ లా. Therefore, sin alpha minus sin beta. Suppose if it is an infinite long conductor, alpha beta tends to pi by t. అంతేగా? Right? Alpha, what happens to alpha? If it is an infinite, this point P, with respect to point P, where will it meet? Very high angle. Pi by 2, pi by 2 almost. Infinite long. Finite, exactly at one end. What happens? Alpha becomes 0 and it all depends on beta only. Suppose if we are selecting a point over here, okay, beta becomes 0, entirely depends on alpha. Any doubts? So now I have discussed about field due to infinite long straight current carrying conductor, field due to a long straight carrying conductor at different places. Okay, the basic derivation. Any doubt in this, please ask me right now. One more important point. Instead, if we are selecting this point on any of these lines, like for example, if we are selecting some point over here, 0. Why? Because for this point, every instant, IDL bar cross R bar is 0. So if we are selecting a point on the conductor, 0. Any doubts? So therefore, now we now know that a current element, a current carrying conductor can be a source of magnetic field, and the direction of the magnetic field lines are given like this. If you are carrying a current carrying conductor along your thumb with the right hand grip position, the curl of the forefinger shows you the direction of the magnetic field lines. In fact, they are circular closed curves. Remember? This is how magnetic field lines are different from electric field lines. Electrostatic field lines are open curves, whereas magnetic field lines are closed curves. Closed curves. So, in fact, the nature of the closed curve indicates two things. Magnetic monopole do not exist, whereas electrostatics isolated positive charge, isolated negative charge exists. But strictly north pole or strictly south pole never exists. If there is a north pole, by default you consider that there is a south pole. So closed lines represents that. The magnetic field lines are closed curves. So magnetic field lines are not conservative in nature. Remember, these field lines are not conservative. If at all it is a conservative basic nature is integral must be 0. You can integral 0 gal. Right. Work non-zero kada. Right. Similarly, we will work on field along the axis of a circular current carrying coil. See, coil means some number of turns. If there is a loop, single turn. So that is a fundamental thing that everyone need to remember. Coil always represents number of turns. Loop means single turn. Any doubt in this? Now you have a current carrying coil carrying current like this. And here you are on the positive x direction. My interest is at a point P. I hope I have introduced all. Remember, this point is at a distance x from the origin. I am assuming the coil is in YZ plane. The coil in YZ plane. Now I am studying an element. Why? To apply Biot-Savart law, I need three things. What are they? I need to know what is ideal bar. I need to know what is R bar. And I need to know what is ideal bar cross R. What is ideal bar? This is the element about which you are speaking about. Okay, got the point? This is the element. Now, basically, at this point, this is the direction of the element. Now, what is ideal bar? DL bar is R d theta, of course, and the direction is one component is along Z, the other component is along Y. What is the Y component? Y component is sine 90 minus theta actually. Hello, this angle is 90 minus theta. Sine 90 minus theta means cos theta. Sine cos 90 minus theta means sine theta. You have one component along positive Y, one component along Z axis, positive Z axis. Right. OA bar. Now, first of all, you got ideal bar. You want OA bar. OA bar, I know, R sin theta j cap minus cos theta k cap. OB bar, X I cap. Now, what is happening? OA bar, OP bar, AP bar. So, AP bar is OP bar minus OA bar. That's what I have done. So, finally, after rearranging ideal bar cross AP bar, you will settle down with this equation. Once, please check everyone. Any doubt? This is the equation. In the exam, every time you don't derive, by the way. Only once we are deriving. In exam, you don't derive. In exam, you need to remember this relation. Right. Now, what is happening? By the way, AP is very simple. X square plus R square. You want only this. This is R, this is X. And you have, this is right angle. So, therefore, hypotenuse X square plus R square under root. So, therefore, you have that relation over here. That relation over here. dB bar is this relation. Finally, you have dB bar. Now, limits. Here, you have this element from here, theta is equal to 0. 2 again, theta is equal to 2 pi, 360 degrees. Now I am integrating that. So I got this relation, mu naught by 4 pi I r square 2 pi I. Don't forget, pi r square I is magnetic moment. Pi r square I is magnetic moment. If there are n terms, that is a magnetic moment. If there are n terms, you will write this like this. V bar is now mu naught by 2 pi 2 m bar by x square plus r square whole to the power of 3 by 2. So what is the direction of magnetic moment? I told you already in the previous week. You take the right hand, take the curl of your 4 fingers along the direction of flow of current. Thumb gives the direction of magnetic moment. Now this loop now acts as a dipole. This is an entire arrangement is equivalent to a magnet. The entire arrangement, like this arrangement, is equivalent to a magnet. North pole, south pole, like this. And this is the expression for magnetic moment. Okay. Remember, you have selected the point on the axis. What if x is equal to 0? You are coming at the center. So center substitution ke baad you will get mu naught Na by 2R. Suppose if the current is passing in by the phase which you are looking at, the current is in anti-clockwise sense, you will have an outward magnetic field. If the current in clockwise sense, for example, you will have inward magnetic field. And not only that, if you draw this function P as a function of X, the graph will be like this. Okay? Got the point? Right. If it is a semicircle, half of this. If it is an arc making an angle phi, field at the center is like this. Vachara? Right. Okay, 2 minutes. We'll pump in jaga pins. Right. That's all. Okay. So if it is possible today, I'll inform. Anyway, SAR will come, no? 3 to 5. That time I will teach here. Right.